this research is on characterizing goosegrass and crabgrass in pasture-based dairy systems. Now, in the pasture-based dairy systems, dairymen are going to rely almost completely on the animals grazing the pasture. This differs from our conventional confinement dairies where they're going to be fed a total mixed ration. Pasture-based dairy systems utilize what we call rotational grazing. So this is a great picture that illustrates rotational grazing. So what they would do is take a larger pasture and divide it into smaller, what they call paddocks. So they move animals from paddock to paddock depending on the level of forage availability. The pasture-based dairies in Georgia are usually on old row crop land, so they use center pivot irrigation, and they irrigate lightly and frequently. They also utilize grazing year-round. So to do this, we have to use a base perennial warm season, typically a Tipton 85 Bermuda grass, and we would oversee this with a winter annual, something like an annual ryegrass. Now, in the year-round grazing, we have a transition period in the spring from when the winter annual grasses are going out and before the warm season perennials have greened back up. Now, this is a perfect time for weeds to germinate, but chemical controls aren't really used in this situation because of long-term grazing restrictions placed on the land after a chemical has been applied. The two emergent weed problems we're seeing are goosegrass, Eleuthine indica, and large crabgrass, Digitaria sanguinalis. Both of these weeds are very competitive with the Bermuda grass in this situation. A couple of reasons are the light and frequent watering, and also the prostrate growth of these weeds allows for more leaf area to be intact after grazing has taken place. Now, the forage quality of crabgrass is well known to be a good forage, but the forage quality of goosegrass is still pretty much unknown. This is a picture taken from a grazing experiment in Eatonton. These were two pastures divided by electric fencing. The pasture on the left was planted in cereal rye, and the pasture on the right was planted in an annual ryegrass. Now, this picture was taken in early June in that transition period, and what we're seeing over here on the left, this green, is crabgrass germinating. So the objectives of my research were to first examine summer annual weed suppression by winter annual forages, and the second experiment was to investigate competitiveness of goosegrass and Bermuda grass at different weed population densities. So the first experiment was done at the Central Georgia Research and Education Center in Eatonton. Russell Bermuda grass was suppressed with 0.5 kilograms per hectare of Roundup, and winter annual forages were seeded directly into the sod. So we used 4 winter annual forages as treatments, consisting of Harrison oats, Renzo Bruzzi cereal rye, Marshall annual ryegrass, and Feast 2 annual ryegrass. We also designed it as a split block design so we could look at the effects of irrigation. So here's a picture. Both of these are the same study. We can see we have 4 blocks with each treatment within each block twice. But down here, the shaded plots represent irrigated plots, and we have each treatment within each irrigation treatment only once. Plots were fertilized with 50 kilograms per hectare of nitrogen, phosphorus, and potassium directly after harvesting, and they were harvested every 28 days to mimic grazing. Now, we evaluated weed populations in 2 ways. First, when the weeds had just germinated, we used a quadrat frame to count individual weed seedlings. We counted the number of individual weed seedlings. But as the weeds matured, we switched to a point frame quadrat system like this one that has 100 points within this quadrat, and we used that to estimate the occupancy percentages of both Bermuda grass and crabgrass. So this picture right here shows one that's mostly Bermuda grass, and this one shows one that's mostly crabgrass. We used analysis of variance, and means were separated by Fisher's least significant difference. And for the second experiment with the weed population densities, I did this at the Plant Science Farm in Watkinsville, Georgia. Goosegrass seed were germinated in a growth chamber before being moved to a greenhouse and then transplanted by hand into a Tipton 85 Bermuda grass. I used different goosegrass population densities as my treatments. So I had a 0, 1, 3, and 5 plants per plot as treatments. Plus we're irrigated, harvested every 14 days, and botanical separation was used for yields. So first I went and I harvested my goosegrass plants, placed them in a bag, then I immediately harvested the Bermuda grass, placed it into a separate bag. Both were dried and weighed for yields. It was a randomized complete block design containing 10 replications using analysis of variance and mean separated by Fisher's LSD. Here's a graph showing our winter annual forage yield distribution throughout the spring transition period. This is for the first experiment. As we can see in March, our ryegrass was our highest yielding treatment. In April, our ryegrass had fallen, and even though everything had, all treatments had more yield, our oats were our highest yielding. And then into May, we can see that our rye had a dramatic loss in yield, followed by our oats, and our Marshall and Feast 2 ryegrasses were the highest. Here's a picture showing the different treatments. This one's Feast 2 ryegrass, Renzo Brothers cereal rye. I don't know how well y'all can see this in the dark, I apologize. And our Harrison oats up here, and our Marshall ryegrass. Here's a rainfall history during the experiment, and I just wanted to point out a couple months. May and July were rainfall surplus months. We had almost double the 30-year average. And June, August, and September were rainfall deficit months. So the ANOVA table for the weed seedling counts show that date, forage, irrigation treatment, and forage by irrigation interaction were all significant. So looking at weed seedling counts by date, our 3 May counts were all significantly higher than our June count. And if you remember back to the rainfall, May was our rainfall surplus month, and June was our rainfall deficit month. And moving into our forage by irrigation interaction, our dryland plots were all non-significant, but our oats in our irrigated plots, our oats and our cereal rye were significantly higher in weed seedlings than our 2 ryegrass cultivars. And now on to our occupancy percentage by date. Once again, if we think back to that rainfall, our July was double the 30-year average in rainfall. And we see that's where our differences are compared to our June, August, September, which were rainfall deficit months. So in July we had significantly less Bermuda grass, while we had significantly higher crabgrass. And our occupancy percentage by irrigation showed a similar effect. In our non-irrigated plots, our Bermuda grass was significantly higher than our crabgrass, and in our irrigated plots, our crabgrass was significantly higher than our Bermuda grass. And now for the second experiment with the weed population densities, ANOVA showed that Bermuda grass was not affected by our goosegrass treatments right here. And so this shows Bermuda grass yields throughout the year, or throughout the summer. And for our treatments, we saw 0 significant difference within each date. This is our goosegrass biomass throughout the experiment. There were significant differences in the first harvest and second harvest, without any after that. And what we were noticing was, when we were harvesting the Bermuda grass, it was practically all just dying. The Bermuda grass was outcompeting the goosegrass, and the goosegrass did not respond well to the harvesting. So we also counted the number of plants we were harvesting. So here, this blue line represents our 5 goosegrass plants per plot. For the first 2, we averaged 5 plants harvested for that 5-plant treatment. But as we went on throughout the year, we had a significant drop in the number of goosegrass that were still alive. So we knew this was not what was happening on the farm. So we went to Waynesboro, Georgia, to a grazing dairy, and we observed cows grazing. And what we saw was that the Bermuda grass was being preferentially grazed over the goosegrass. The cows literally would walk up to the goosegrass, sniff around, take a small bite, and then walk off. So for 2012, we made some modifications to mimic livestock avoidance. So we doubled the number of treatments, and we didn't harvest the goosegrass in the new treatments. We still had the same population densities, but we did not harvest the goosegrass in those treatments. And we're also going to look at some forage quality and some prussic acid, which is a toxin. Unfortunately, I don't have the data yet. I tried to get it in this, but I didn't have enough time. So to summarize, for the first experiment, ryegrass suppresses summer annual weeds under rainfall and irrigation. And for the second experiment, we did not mimic pasture conditions, and so the 2012 experiment was modified to do so, but the data is not yet available. And I have some acknowledgments here. Dr. Nick Hills, my major professor, Dr. William Vinsel, and Dr. Dennis Hancock are my committee members. And a big shout out to Kevin Roach in the back. He helped me